Why your brain might never explain what it's like to be you.
Audio summary of The Conscious Mind in Search of a Fundamental Theory by David J. Chalmers.
Why this book matters for the Book Vault. It addresses the most fundamental question about minds and machines that future civilizations must answer. Can consciousness emerge from physical computation, or is it something additional? As we approach the point where AI systems might be genuinely conscious, Chalmers' framework provides the conceptual tools to distinguish systems that merely process information from those that truly experience. Without understanding this distinction, future builders cannot make ethical decisions about artificial minds, mind uploading, or cognitive enhancement technologies. It provides a rigorous philosophical framework for building a science of consciousness, despite its irreducibility to physics. Through structural coherence and organizational invariance, Chalmers shows how empirical research can make genuine progress, even though experience cannot be reduced to brain mechanics. It offers intellectual humility about what remains genuinely uncertain, while maintaining clarity about what we can know. Chalmers explicitly marks his speculative ideas as most likely to be entirely wrong, while standing firm on core principles.
Chapter 1. The Mystery That Refuses to Dissolve. No amount of brain science can explain why there's something it feels like to see red. Even if we mapped every neuron and understood every process completely, the question would remain, why is any of this accompanied by experience? Physics has conquered the fundamental forces, biology decoded life itself, neuroscience traces pathways from stimulus to response with stunning precision. Yet the most basic fact about human existence, that there is something it feels like to be you, remains completely unexplained by all of this progress. When you see a sunset's orange glow, science can explain the wavelengths hitting your retina, the chemical cascades in photoreceptors, the neural signals racing through visual cortex, even the behavioral responses and memory formation that follows. But it cannot explain why there is a subjective experience of orangeness, why orange feels the way it does rather than feeling like something completely different, or feeling like nothing at all. Even with complete knowledge of brain mechanics, the question persists, why is there experience? Chalmers distinguishes between easy problems and the hard problem of consciousness. The easy problems involved explaining cognitive functions, attention, memory, verbal reports, behavior control. These are staggeringly complex, but we know how to approach them, identify neural and computational mechanisms that perform these functions. The hard problem is fundamentally different. It asks why any of these mechanisms are accompanied by subjective experience. Why does information integration in visual cortex generate the experience of seeing? This question has no clear research strategy using physical explanations alone. Consider two beings, physically identical, down to the last atom. Same neurons firing in the same patterns, producing the same behaviors and words. Both claim to feel pain, both report seeing colors, both describe emotions. But one is you, consciously experiencing everything. The other is a philosophical zombie, processing information identically but experiencing nothing. All is dark inside. There's nothing it's like to be the zombie. The fact that we can coherently conceive of such zombies reveals consciousness involves something beyond physical processes. You could know every physical fact about the zombie's brain and still not know whether consciousness is present. Physical facts alone don't logically entail facts about experience. Meanwhile, a being could lack consciousness entirely, no one home, pure mechanism, while being functionally indistinguishable from you. This shows consciousness can't be fully captured by functional descriptions. It's like the difference between a weather report and actually feeling rain on your skin. The report can give you all the data, temperature, wind speed, precipitation levels, atmospheric pressure. You could process this information perfectly, respond to it appropriately, even describe the weather accurately. But none of this is the same as the direct experience of standing in rain. The sensation of cold water, the sound of drops, the smell of wet earth. These experiences contain something the data alone cannot capture. Similarly, all the information processing in the world doesn't add up to the feeling of what it's like to be conscious. Chapter 2. Why Every Solution Fails. Scientists keep trying to solve consciousness by explaining how brains perform functions, but consciousness isn't defined by what it does, it's defined by what it feels like. Every solution that ignores this fails before it begins. Bernard Baars proposes consciousness is a global workspace where information becomes available to multiple cognitive systems. This explains reportability and attention, how information gets shared across the brain. But it doesn't explain why global availability should feel like anything. Why should information broadcast to generate experience?
Francis Crick and Christoph Koch suggest 40 Hz neural oscillations might be the key. These oscillations might explain how different features get bound into unified perceptions. But again, why should oscillations feel like something? The question, why should 40 Hz rhythms generate redness, is just as mysterious as why should any neural activity generate experience? Roger Penrose reaches for quantum mechanics, proposing non-algorithmic collapse in microtubules might explain consciousness. Even if true, this only explains certain computational properties. Why should quantum collapse, rather than any other physical process, be accompanied by subjective experience? Quantum mechanics doesn't make the hard problem any easier. Daniel Dennett's multiple drafts model involves many small cognitive agents competing for attention, with no central control. The model might explain reportability and information processing, but it tells us nothing about why there should be something it's like to be a system undergoing these processes. The problem isn't that the model is incomplete in its details, it explains the wrong thing entirely. Evolution can't rescue us either. Natural selection explains why we have information processing, threat detection, and behavioral control, but it can't explain why these functions are accompanied by consciousness. Your philosophical zombie twin would survive and reproduce equally well. Any function consciousness serves, unconscious mechanisms could serve identically. Evolution selects for what systems do, not for inner experience. Look at blind sight patients. Damage to primary visual cortex leaves them blind in parts of their visual field. They report seeing nothing, yet when forced to guess where objects are, they point accurately. The information still reaches brain regions controlling behavior, just not regions generating conscious experience. They process visual information without experiencing vision. This demonstrates consciousness and information processing can come apart. The function happens without the feeling. Similarly, subliminal perception influences choices and reactions without entering awareness. Information shapes behavior despite absence of experience. These cases prove consciousness isn't just another word for information processing. It's something additional that sometimes accompanies processing. Once you see this pattern, you can't unsee it. Every proposed solution becomes transparent. Researchers identify some brain mechanism, synchronization, feedback loops, information integration, whatever, then claim that's consciousness. But the hard problem remains, why should this mechanism feel like anything? It's like someone explaining traffic flow by describing roads and vehicles, then claiming they've explained why driving feels like something. The functional explanation misses the experiential reality entirely. The hard problem stands untouched, waiting. Chapter 3. The Radical Solution. If consciousness can't be reduced to physics, we need to add it to physics as a fundamental feature. The way electromagnetism couldn't be reduced to mechanics, so physics added electromagnetic fields as fundamental. Throughout scientific history, progress has required recognizing when existing primitives can't explain new phenomena. Mass and distance couldn't explain magnetism,
So Maxwell introduced electromagnetic charge as fundamental. Mechanics couldn't explain thermodynamics, so he added entropy as fundamental. Similarly, physics cannot explain consciousness, so consciousness must join the list of fundamental features. Chalmers proposes property dualism. Mental properties are irreducible features of reality, not separate substances, but fundamental properties arising from certain physical configurations. This isn't Cartesian dualism of immaterial souls pushing atoms. Physics remains causally closed. Every physical event has sufficient physical causes. Consciousness doesn't interfere with neurons any more than electromagnetic fields interfere with gravity. Rather, consciousness is an additional feature that certain physical processes instantiate according to psychophysical laws. These psychophysical laws would be basic principles of nature specifying which physical processes give rise to which experiences. Just as gravitational laws determine how mass creates space-time curvature, psychophysical laws determine how neural organization creates subjective experience. We cannot derive these laws from physics any more than we derive gravity from electromagnetism. They're fundamental features of how our universe works. The evidence for such laws is compelling. If you precisely replicated someone's brain structure, you'd replicate their consciousness, not because consciousness logically follows from neurostructure, but because psychophysical laws connect that structure to that experience. The connection is lawful and systematic, even though it's not logically necessary. A universe with different psychophysical laws might have the same brains producing different experiences, or no experiences at all. Throughout physics, we've progressed by accepting new fundamental features. 19th-century scientists tried desperately to explain electromagnetic phenomena using mechanical principles. This failed. Only by accepting electromagnetic charge and fields as fundamental, governed by their own laws, could physics progress. Consciousness requires the same recognition. The features and laws of physical theory aren't enough. For a theory of consciousness, new fundamental features and laws are needed. Think of consciousness science as mapping unexplored territory using two incomplete maps. One map, neuroscience, charts the physical landscape, mountains of neurons, rivers of neurotransmitters, valleys of brain regions. The other map, phenomenology, charts the experiential landscape, the felt qualities of red and blue, pain and pleasure, joy and sorrow. Neither map alone suffices, but where they overlap and their structures match, where every mountain on one map aligns with a mountain on the other, we learn something real. Psychophysical laws are the projection that relates these maps. Chapter 4. The Architecture of Scientific Progress. The remarkable structural match between what we experience and what we cognitively process provides the foundation for an empirical science of consciousness. The most important empirical fact about consciousness is its systematic relationship to cognition. What we consciously experience corresponds almost perfectly to what our cognitive systems register and make available for reasoning and behavior. This coherence principle provides the bridge between subjective experience and objective measurement. When you see a red book, you have both a conscious visual experience of redness and a cognitive state where information about the book's redness is directly accessible to your reasoning and behavior. You can point to the book, comment on its color, pick it up deliberately. The information is functionally available, playing a role in how you think and act. The correspondence goes deeper than mere presence or absence. The structure of your experience mirrors the structure of your awareness. If you see bright red next to dull yellow, creating a particular contrast in your visual field, your cognitive systems represent that same contrast. They register the difference in brightness, the spatial relationship, the color categories. Every structural feature of your experience, the geometry of your visual field, the intensity of sensations, the relationships between different qualities, shows up in the functional organization of your cognitive processes. This structural coherence generates testable predictions. If we discover new structural features in how the brain processes some domain, we can predict corresponding structural features in experience. Conversely, if we discover structural features in experience through careful phenomenology, we can predict corresponding functional organization. This bidirectional bridge enables empirical research despite consciousness being irreducible to physical processes. Consider a thought experiment that reveals consciousness depends on functional organization rather than specific physical substrate. Start with your normal, conscious brain. Replace one neuron with a silicon chip that perfectly duplicates that neuron's input-output function. Your consciousness continues unchanged. Losing one neuron among billions cannot plausibly eliminate all experience. Continue replacing neurons one by one, each time preserving perfect functional equivalence. After 10% replacement, 50%, 90%, finally reaching a fully silicon brain. If the silicon version lacks consciousness, when exactly did experience disappear? Did replacing one specific neuron suddenly extinguish your entire inner life? Such discontinuity seems absurd. Consciousness cannot depend on such arbitrary physical boundaries. The alternative, gradually fading consciousness, is even more problematic. Imagine someone halfway through replacement, experiencing degraded consciousness. Where you see vivid red, they see pale pink. Yet functionally, they're identical to you. They claim to see vivid colors, report rich experiences, show no signs of degradation. They would be massively mistaken about their own conscious states despite being rational and attentive. This radical dissociation between experience and self-knowledge is extraordinarily implausible. The only reasonable conclusion, silicon substitution preserves consciousness throughout. What matters for experience is not the specific physical substrate, but the pattern of causal organization. This is the principle of organizational invariance. Systems with identical functional organization have identical conscious experiences, regardless of what physical material implements that organization. Organizational invariance means consciousness is multiply realizable. It can arise in silicon computers, biological digital hybrids, or any system that implements the right functional organization. This opens the door to artificial consciousness, mind uploading, and enhancement technologies, not as science fiction speculation, but as logical consequences of how consciousness relates to physical processes. For neuroscience, structural coherence means mapping information processing reveals experience structure. When scientists trace how visual cortex integrates information about shape, color, and motion, they're indirectly mapping the geometry of visual experience. Progress is possible despite irreducibility because the two domains, physical processing and phenomenal experience, maintain systematic structural correspondence. Chapter 5. Information as the bridge. Chalmers explores whether information itself might be fundamental to reality, with physical processes and conscious experiences being two aspects of the same underlying informational structure. Before exploring these ideas, we must note that Chalmers himself describes them as sketchy and speculative, and most likely to be entirely wrong. As he explicitly states, personally, I am much more confident of naturalistic dualism than I am of panpsychism. What follows is exploratory theorizing, a framework for thinking about consciousness rather than settled conclusions. Information appears in two fundamentally different ways in our universe. Physical information is realized through causation, through differences that make a difference in the world. When a switch is up rather than down, this difference affects whether lights turn on. Phenomenal information is realized through experience. When you see red rather than blue, you experience a specific location in color space. The difference is directly present in consciousness. The striking fact, these appear to be the same information spaces realized twice. The three-dimensional structure of color experience, hue, saturation, brightness, corresponds exactly to the three-dimensional structure of color processing in visual cortex. Every distinction in experience maps to a distinction in neural processing. It's as if information has two faces, a physical face seen from outside through its causal role, and a phenomenal face experienced from inside through consciousness. This suggests a possible double aspect principle. Information states might have both physical and phenomenal properties. When your brain realizes a complex information state through neural activity, that very same state might be realized phenomenally in your consciousness. The physical aspect is what the information does, its causal role. The phenomenal aspect is what it feels like, its intrinsic nature. Physics describes the world entirely in relational terms. Mass attracts, charge repels, but never tells us what mass or charge intrinsically is. Physics gives us the scaffolding of reality without the filling. Perhaps consciousness is this filling. Perhaps the intrinsic nature of physical states, which physics leaves unspecified, is phenomenal or proto-phenomenal. If information has a phenomenal aspect wherever it appears, experience might be ubiquitous. A thermostat realizes a simple three-state information space. If information has phenomenal aspects universally, the thermostat might have three primitive experiential states, not the complex experience of seeing red or feeling joy, but simple qualitative differences we cannot imagine. This seems absurd at first, but Chalmers argues it may be no more absurd than the alternatives. As we move down the scale of complexity from humans to simpler systems, where exactly does consciousness disappear? Before vanishing entirely, we should reach maximally simple phenomenology. The thermostat might realize experience in its simplest possible form, bare phenomenal flashes without cognitive structure. The resistance often stems from conflating phenomenal consciousness with other mental features requiring complexity. Self-consciousness, intelligence, thought, emotions. A thermostat would have none of these. It would simply have primitive experiential states, far simpler than anything we can sympathetically imagine. This framework faces serious challenges. The grain problem asks, how could micro-phenomenal properties underlying fundamental physics constitute our smooth, unified conscious experiences? Your red experience feels homogeneous, not like trillions of tiny micro-experiences corresponding to particles in your visual cortex. Chalmers considers possible solutions, but acknowledges none are fully satisfactory. Perhaps phenomenal part-whole relations work differently than we assume. Perhaps micro-properties add up, reflecting informational structure rather than spatial structure. Or perhaps the relation between micro and macro phenomenology is lawful rather than constitutive. The grain problem remains the hardest challenge for information-based views. Many other questions remain open. Which physically realized information spaces have phenomenal counterparts? How does the framework extend to complex emotions and thoughts? What marks the boundary between conscious and unconscious information processing? These questions show how far we remain from a complete theory. Why include such speculative ideas in the book vault? Because exploring them illustrates how we might construct fundamental theories of consciousness. Even if the information-based approach fails, insights about information's role, the structural match between physical and phenomenal, and the deep connection between intrinsic properties and phenomenology may prove valuable in alternative frameworks. The traditional objection that theories of consciousness are too speculative misses the real problem. The issue isn't speculation, but lack of specificity. A simple theory predicting all experiential details from physical facts would be extraordinary, even if initially speculative. We don't yet have such a theory, but exploring possibilities teaches us about the challenges we face.
Chapter 6: The Quantum Connection and Machine Minds. Quantum mechanics and consciousness both challenge our assumptions about reality's fundamental nature, and they might be more connected than we think. Can computers be genuinely conscious? Chalmers argues yes, based on organizational invariance. If consciousness depends on functional organization rather than biological substrate, then appropriately programmed computers can possess genuine consciousness, not simulated, but truly experience it. The fading and dancing qualia arguments establish this conclusion. When we imagine gradually replacing biological neurons with functionally equivalent silicon chips, consciousness must be preserved throughout the replacement, otherwise we face absurd scenarios. Either consciousness suddenly vanishes when one particular neuron is replaced, arbitrary discontinuity, or experiences gradually fade while the system continues reporting normal rich experiences, massive self-deception. This addresses Searle's famous Chinese room argument. A person manually following rules to manipulate Chinese symbols doesn't understand Chinese. But this person isn't the locus of understanding. They're facilitating causal interactions between symbol states, organized to mirror a Chinese speaker's brain. The system as a whole, not the individual following rules, implements the relevant functional organization. Quantum mechanics makes astoundingly accurate predictions, but interpreting what reality must be like for those predictions to hold presents profound puzzles. At quantum scales, systems exist in superpositions, states that are somehow multiple states at once. An electron spin isn't simply up or down, but a combination of both. When measured, we always find definite values. But what counts as measurement? Why does observation force reality to choose? Some suggest consciousness triggers collapse, that conscious observation transforms quantum superpositions into classical reality. This would make consciousness fundamental to physical law. But this interpretation faces challenges. What degree of consciousness suffices? Does a mouse collapse wave functions? An insect?
The Everett interpretation offers a radically different picture. Only the Schrödinger equation governs reality. No collapse ever occurs. The world remains in superposition at every level. When you observe Schrödinger's cat, you don't collapse its state. You entangle with it, creating a superposition of you observing a live cat and you observing a dead cat. Both exist within the universal wave function. Chalmers' theory of consciousness provides surprising support for this interpretation. If consciousness arises from causal organization, then a superposed brain state should give rise to multiple distinct streams of consciousness, one for each component exhibiting coherent causal dynamics. This makes the proliferation of parallel worlds more comprehensible. Each branch contains genuine conscious observers experiencing definite states. Yet even Chalmers himself finds the Everett interpretation emotionally impossible to accept despite its intellectual appeal. As he confesses, "I cannot wholeheartedly believe it. Maybe it is simply too strange to believe." If forced to bet his life on its truth, he would not be brave enough to bet on it at the end of the day. The probability problem remains the most significant difficulty. Quantum mechanics predicts certain measurement outcomes are more probable than others. But in Everett's interpretation, all outcomes occur. Every possible result happens in some branch. If both spin up and spin down definitely occur, what do the probabilities mean? This problem remains unsolved, casting doubt on whether the interpretation truly works. As Chalmers notes, all interpretations of quantum mechanics are to some extent crazy. Each requires accepting something deeply counterintuitive. The Everett interpretation is, in many ways, the most attractive theoretically. It requires only the Schrödinger equation, but its implications are almost too strange to believe. We may never be able to accept it emotionally, but we should take seriously the possibility it's true.
The 3 essential takeaways. First, the core principle. Consciousness cannot be reduced to physical processes and must be recognized as a fundamental feature of reality, connected to physics through psychophysical laws we must discover. Why it matters? This determines whether we're looking for the right explanations or chasing an impossible reduction. Second, the practical method. Use structural coherence to build empirical consciousness science. Map how information is processed, cognition, to infer how it's experienced, consciousness, while recognizing organizational invariance means the same functional patterns produce the same experiences regardless of substrate. First step: when evaluating consciousness research, distinguish claims about experience from claims about cognitive function. Most research addresses function, while claiming to address experience. Third, the speculative horizon. Information might bridge physical and phenomenal domains, potentially suggesting experience is more widespread than assumed, but these ideas remain highly uncertain and should be held tentatively. Your role? Engage seriously with speculative possibilities while maintaining intellectual humility about what remains unknown.